Hello, good morning. I'm Sudarshan Naik. Today, again, I present here to teach about physics, but it is a long time. After a long time, I'm making YouTube video for physics. So, let's and learn something new about physics. So, last class I taught about gravitation and the relation between gravitation and Kepler's law, and almost you know about first law of Kepler's first law, and it is said that nothing but it is a revolution of any planet around the sun is elliptical, and the shape of elliptical is like this. This is the shape of elliptical. Okay, this is the shape of elliptical. There is two forces on this elliptical shape, and radius is not equal every point or around the point, so its eccentricity is not equal to 0 or not equal to something like if the center is here like this and here is center, so eccentricity is less than equal to 1. There are two forces, that is S1 and S2, and this is the elliptical path. Elliptical path or elliptical orbit. Okay, so and this region, this is suppose that here is sun is present, like sun is present at suppose the sun at S1, then this region is called perihelion, and perihelion means the point, let there be very close to the sun, as if the point let there be very close to the sun, very close, and it is called the perihelion. Peri means close, okay, and helio means perihelions, that is there is something clue, learn about this. Helios means sun, and peri means close, that is called perihelions. This point is called, suppose that P1, that is P1 is just close to the sun, then it is called perihelion. And if the point is another end, that is this end, that is called P2, and the distance like this is called aphelion. Apo means far, or helia, and helios means, this is the Greek word, the combination of Greek word helios and apo is called aphelion. The Greek word helios and peri and helios is a combination, that is the perihelion. It is the perihelion point, and it is the distance. How much distance will be, you can say that 47.1 million kilometer, that is 10 to the power 6 kilometer, and the distance between like this and this distance is known as how much, that is 1 152.1 into 10 to the power 6 kilometer. Okay, when we convert this one in meter, that is 10 to the power 9 meter, and this is known as 2.1 billion kilometer. Okay, that is called billion kilometer, billion meter, sorry, billion meter, and it is converted into the billion meter. So billion meter is how much? 147.1 billion meter. This is the distance. If suppose that the earth is present at a one foci out of these two foci S1 and S2, suppose the earth sun is at a foci S, then its elliptical path will be like this, and here is sun is present. If P1 is the perihelion point and its distance between P and sun, P and S1, that is of 147.1 billion meter, and P2 is the farthest point from the sun, and it is called aphelion, and its distance is how much? 152.1 billion meter. Okay, this region is called perihelion and this is region called aphelion. When the planet, or suppose that earth is moving around the sun, then its revolution, the revolution of the earth in the elliptical, and it is the first law of Kepler's first law. It is the Kepler's first law, and all the planet, 8 planets revolve around the sun, and its elliptical path like this. So we know more about this elliptical path. Okay, suppose that here question is what? Why all the planet is revolved in an elliptical path? The main reason is we know. Okay, we know about force. When the body is revolved in a circular path, then there is a centripetal force. Centripetal force acting toward the center, which is linked to the radius like this. Suppose a body is revolving around this is velocity v, and this is the radius, this is r, this is called center, and body mass of the body is called m. When the body is revolved around the sun, there is a linear path, linear momentum, that is called linear momentum. Okay, linear momentum is how much? This is called linear momentum. This is 90 degree, and when the body is in a angular momentum, this is not linear, this is angular momentum. Okay, so this is a radius and this is the velocity, this is the linear velocity. This is called linear velocity. The product of radius and momentum is called the angular momentum. When the body is in the angular momentum, there will be a circular path, and when you have the circular path, there will be the angular acceleration. Angular acceleration is called v square by r. and when the body is here moving weight or mass m, then it will be the centripetal force. This is m and this is m, both side m. Okay, multiply both side m like this, multiply both side m, because the body of mass moving in a circular path, that is m, and then multiply this one m se b square by r into m, and this is called force. This is called force. This is force. Force F equal to ma. But the force acting in a angular momentum, that is the angular momentum linear. This is the revolving around the sun. This is, suppose that this is the sun and the planet is here and revolve around the sun. In this case, there is the centripetal. There is the centripetal force Fc. Fc is here v square m v square by r. This is the equation. This is the equation. When the body is revolved in a elliptical or circular path, in this case there will be a centripetal force. Okay, Fc is called the centripetal force. M is the mass. The mass is body of mass moving around the circular path or around our sun, and v the velocity of the moving body, and r is if this is the r, this the eccentricity is 0, then e equal to 0, then it will be the circular path. Circular path, and e is not equal to 0, less than or equal, not equal to or less than equal to 0, then it is called elliptical. So here is, let's know about more thing about this elliptical path. Why? What is the reason behind it? When the planet is moving around the sun, then all planet its path is elliptical. All planet revolves around the sun in the path of elliptical or ellipse. So what is the main reason is study. Now let's main reason is what is the reason behind it? Like this. Okay, here is S1. S1, this is point is S1. This is, here is sun, and at distance like this. Okay, this is the distance like this. This is the point, and this point is very closer to the surface, sun S1, and here is point, here is point, here is point. This is the point like this. This is the point like this. This. So here is this is the regions. This is called the aphelion. Aphelion, and this is called the perihelion. Perihelion. And here the centripetal force is like this. Suppose that this is the r and this is the distance between the circumference and the center. If the sun is here, then this region called perihelion region, and this region is called aphelion region. So this is the distance. This is the distance r, and this distance is called AP, radius of aphelion, and this distance is called PE, perihelion. When the body is moving in a circular path or in an elliptical path, then the centripetal force acting on this here. Centripetal force. We know that when the body revolves in a circular path, then centripetal force acting. Here is centripetal force. Suppose that here is centripetal force. Centripetal force. Centripetal force Fc equal to mdx squared by r. Suppose that we taking, this is the earth, this is the mass of earth, and its mass value is 5.97 into 10 to the power 24 kg. This is the mass of earth is moving around the sun in elliptical path. Then it is the we know that mass, this is the mass, this is the 5.97 into 10 to the power 24, and the velocity of the earth around the sun is very high speed, that is 30 km per second. It means that 30,000 km per second. So here is velocity of earth around the sun. Velocity of earth around the sun is 3 into 10 to the power 4 km per hour. Okay, that is, this is the kilometer per hour. So like this, this is per meter per second, kilometer per second, you will say that 30 kilometer per second. Okay, so here is 30 kilometer means 30 kilometer, that is kilometer per second, that is per second is how much kilometer, 30 kilometer per second. So you can say 30 kilometer, you can meter per second, this is 30 kilometer. Okay, just correct this one, 30 kilometer per second moving around the sun. It is very high speed with in the elliptical path. This is the elliptical path. Okay, and this elliptical path is like this. When we this is the perihelion, and perihelion is how much? This is perihelion RP, R peri. You can write here peri, that is called 147.1 million kilometer, and it is converted into meter, that is 147.1 into 10 to the power 9 meter. When they put the value of put on this equation, then we find the centripetal force on the perihelion regions. So we find out this one. Okay, put the value of, that is Fc, mass of earth, that is 5.97 into 10 to the power 24. This is velocity of earth around the sun, that is 3 into 10 to the power 4, that is meter per second, that is kilometer per second, and this is the meter per second. Okay, so here the perihelion distance is how much? This is the perihelion distance, that is 147.1 into 10 to the power 9 meter. When we calculate this one, then we find when the earth is moving in a elliptical path, then here is the centripetal force acting. How much centripetal force acting? So we find this one. So where is my calculator? We use the calculator because the accuracy, for the accurate calculation. So here we write here that is 5.97 into 3. This is 3 into 3, 9. Okay, this is the power of this is the power 2 power, so 3 power. Okay, power 2, that is 9, that is called 9. When we multiply with 9, okay, multiply with 9, that is called 5 3 into 7 3, and this is the exponential part. This is 8 10 to the power 24 plus 8. Okay, here is 147.1 into 10 to the power 8. We calculate this one, and this is 53.73 by 147.1. This is 10 to the power 32, and this is 9. Okay, oh sorry, this is 9. Okay, 9. So it is 9, that is this is 10 to the power how much, 23. Okay, and here is how much, 53.73 is divided by 147.1, that is called 3. This is called 0.36526. This is the centripetal force, that is Newton. Okay, centripetal force, I can say Newton, 1 Newton. When they put the value of like this is kilometer meter per second, that is something here is Newton. 1 Newton is, we know that kilometer per second square, kilometer meter per second square. So you can say that this is the same unit for force. Here is force, the Newton is here. So the point is shifted like this. When the point is shifted right side, then it will be 3.6526. One point is right side, then 10 to the power minus 1. Okay, so this is 10 to the power 23, and this is Newton, and 3.65, this is 3, you can say that, into 10 to the power 22 Newton. This is the huge forces acting on the earth when the earth is on the region of perihelion. When the earth is moving around this elliptical path, on the elliptical path around the sun, then the region of perihelion, there is the huge force acting. This is the huge centripetal force is acting. Here is centripetal force, this is the centripetal force, and these regions, suppose that this is the region, this is the region, this is the region, this is the region. These regions, suppose this is the approximate equal to 4 point, this is the 4, this is 147.1 million kilometer. So here is the centripetal force is how much? This is called 3.65 into 10 to the power 20 Newton. This is the huge force. When the earth is moving on the circular path like this, just cross this one, just faster than this is faster, this cross this one, and this move in the on the elliptical path like this. Now we calculate the value of aphelion, that is called aphelion regions. This is the aphelion regions. Here we find out also find out the centripetal force on the aphelion regions. If the distance is 152, 100, like this is the regions. Here is 152.1 million kilometer, that is 152.1 into 10 to the power 9 meter, like this. Same things, the centripetal force on the earth like this. This is the earth, mass of earth, this is the mass of earth, and this is moving like this, velocity, this is the velocity of earth. So centripetal force of aphelion, that is ME, velocity of earth, mass of earth, and aphelion. Put the value of, here is mass of earth equal to 5.97 into 10 to the power 24 kg. Velocity of earth 30 km per second. It means that 30 meter per second, and this is called 3 into 10 to the power 4 meter per second. And this is the aphelion, that is aphelion is 152.1 into 10 to the power 9 meter. When the putting the value of mass, velocity and aphelion distance, then we can get centripetal force of the earth when it is moving around the sun at the region of aphelion. So here is how much, 5.97 into 10 to the power 24, and this is 3 into 10 to the power 4 power 2, and this is aphelion 152.1 into 10 to the power 9. This is the value of 53.73 into 10 to the power 24 plus 8, and this is 152.1 into 10 to the power 9, that is called 153.73, 152.1, and this is 10 to the power 32 minus 9, and it is called how much? 53.73 is divided by 152.1, 152.1, okay, that is 0.3525 in 10 to the power, that is 23 Newton. When the point is shifted right side, then it is 3.525 into 10 to the power 23 minus, just write this one. When the point is shifted right side, then it is 10 to the power minus 1 and 10 to the power 23 Newton, and then it will simplify, and this is 2.525, okay, and it is 10 to the power 22 Newton. This is the force acting on the aphelion when the earth is just moving at the region of aphelion, and this is the force acting on the region of perihelion. And average, you can say that this is the average force is how much? This is the average. Here is average. This is the ordinate regions. This is the regions. Suppose that this is the point. This is the point. Suppose here is sun acting, and this is the point, and this is the force acting on this point is like this. Centripetal force is acting here. Centripetal force acting at this one, and at this is, and centripetal force is like this. Suppose that like this, centripetal force is like this, okay. So centripetal force is like this. This is the force, and centripetal force acting. Centripetal force acting this one. This is the force is like this. This is the force is like this. The main forces is like this. When add this one, this is the minimum, and this is the minimum, and this is the maximum, and add this one, this is the average. Here is the centripetal force. Here is the centripetal force acting. Here the centripetal force is acting. This is FC. The mean. This is called mean. Average. This is the centripetal force is acting like this. Here is force. Centripetal force at mean. Average. This average is how much? That is 3. Centripetal force at perihelion plus centripetal force at aphelion. Centripetal force at aphelion divided by 2, and this is called how much? This is 3.65 into 10 to the power 22 plus, and 22 plus, okay, This is 3, you can write this one, this is 3. Yeah, this is 2 digit is taken. Okay, so like 3.52 into 10 to the power 22 Newton, and this is average, this is 2. Add this one, like adding this one, just add, this is 7, this is 11, 1, and this 6, 6, 7, that is 2, this 10 to the power 22 Newton. Calculate the value of 7.17 divided by 2, that is exact value is 3, that is 3.585, this 3.585. okay, this is the 6 and this is the 585, this is the 10 to the power 22 Newton. This is the average force on this place. When it is also average, it will be also average this one, this is the also average this one. If the value is like this, we write another marker like this. Okay, so here we find out the value of here the centripetal force is how much here. This is the greater, here is greater, then it is the average, and this is here the centripetal force at between the decreasing of the centripetal force is decreasing when the earth moving in the aphelion regions. When the body is moving in the aphelion regions, then the centripetal force is just decreasing. Okay, here is how much, this is the when average force between these regions, the average force, this is the average centripetal force between this and this point. We add this one and divided by 2, then we get the average centripetal force at this point. This is the just edge of the perihelion. This is the edge of the perihelion, that is called how much? This is 3.58 plus this is 3.52 10 to the power 22 divided by 2, that is called how much? This is 0, this is 5, 5, 10, 11, and this is called 7. This is 2 into 10 to the power 22. When divided this one, this is 3.5, you can say 5. Okay, 0, 10, 11, and this is 7. Okay, this is the 2, 5, 5. Okay, this is the 10 to the power 22 Newton. This is the 10 to the power Newtons, and then here is just decreasing. Here is, look this one, here is like this. Here is force is acting how much? 3.58 into 10 to the power 22 Newton. Here is force acting 3.55 into 10 to the power 22 Newton. Here is force, centripetal force acting 3.5 into 10 to the power 22. And when it is now this is the here in the same things, the same distance, here is the same distance, then the force will be 3.55 into 10 to the power 22 Newton, and here is 3.58 into 10 to the power 22 Newton. This is the force acting when the force moves from the perihelion to aphelion, then the force is decreasing. When the earth is moving from the aphelion to the perihelion, then the force will be increasing. This is called increasing, and this is called decreasing. Decreasing centripetal force from perihelion helium to aphelion. When the earth is moving, that is called earth, and earth is moving velocity v and just moving on this helium in this, then increasing. When the force is increasing, here is also increasing. What is the force at the point? We find out, even find out this one. Okay, here is find out. Okay, now find out this one. Here is, we know that here is the 3.65 into 10 to the power 22 Newton force is acting at the perihelion point. I mean, here is the point is this one. Then what is the mean of at the, here is mean, this is the mean. The mean force is how much? Here is force, this is the centripetal force of the earth at the just closer to the perihelion region. Then it is how much? This is the maximum and this is the minimum. The adding this one, 3.65 plus 3.58, okay, 10 to the power 22 Newton, and this is called 2, and this is how much? This is 2.7 by 2 into 10 to the power 22 Newton. This is how much? Okay, 3.65 plus 3.58, that is divided by 2, that is called 3.615 into 10 to the power 22 Newton. Here is 3.65 and here is 3.615. So you can say this is the only 2 digit is taken here. So here is and when it is, here is also here is the centripetal force is how much? Adding this and divided by 2, then it is the mean between this portion. So here is how much? This is this and this is add this one, this and this add and divided by 2, how much? 6, okay, 3.65 plus 3.61 divided by 2, that is 3.63 into 10 to the power 22 Newton. Here is force is acting like this. When the earth is close the perihelion, then it is the maximum force is acting here, and after crossing the perihelion regions, then the centripetal force just decreasing. Here is 3.85, here is 3.55, here is 3.52, and this is the decreasing, and it is the turn like this. And when the turn like this, here is the point 3.55, and then it is the increasing. Here is 3.58, here is 3.55, and then 3.55 into 10 to the power 22 newtons. Here is 3.51, here is 3.51, and here is 3.6. So there is like this. Here is also 3.63. Here is 3.63 into 10 to the power 22 Newton. So how can you think? Do you think if the planet is moving around the sun, and like the centripetal force is like this, here is increasing, here is a maximum, here is maximum, and just like decreasing, and there's a minimum, and then it is increasing and maximum. So just like this, moving like this. Okay, this is the centripetal force is not constant. Centripetal force is not constant, and in this case we can understand that it will be, the path will be not circle. If the centripetal force is acting constant, everywhere is radius is fixed. Here is not, radius is not fixed. Radius is just changing. Here is changing, here is changing, here is changing, here is changing, here is changing. So here radius is changing, then the centripetal force also changing, just varies from one by one point to another point. So we can say that it is only and only elliptical path, not a circle, because here is proof. Here is the maximum, this is just lesser than maximum, and it is also lesser than second one, and this one is lesser than after this one, and this is minimum, and this is increasing this one, and this is increasing then get one, and another, this is increasing another get one. So this is the reason, due to the centripetal force, due to this, like this centripetal force is acting on the earth while it is moving around the sun. So it's the path is not circle. Okay, the path of the earth around the sun is not circle. Here is proof. So we know that every planet, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, every planet which revolve around the sun, all the path of the planet is elliptical. So this is the proof. So thank you for watching this video. Next video coming very soon. Just wait.